All right, my lovelies, last set of notes that you will be hearing my wonderful voice until next year. Okay, what we're going to do is we're going to learn about adding and subtracting radicals. That works different than the multiplication does. Okay, so this is the rule in math notation. And what this tells you is that the radical has to be exactly the same, has to have the exact same index, has to have the exact same radicand, and then you just treat it like it's a variable. So you're just going to carry it over here and not change it. And you're going to take the coefficients here, A and B, and you're going to either add them or subtract them according to what it says to do. Okay? So like when we look down here at the fourth root of 10 plus 7 times the fourth root of 10, they both have the fourth root of 10. So that's just going to stay. I'm going to take the 7, I'm going to add it to the number in front of this, which is a 1. So 1 plus 7 is 8. Your final answer is 8 times the fourth root of 10. Pretty simple, easy, huh? Okay. Now, of course, they're going to throw you problems like this. The third root of 54 minus the third root of 2. They're not the same. Now, we don't want to make the 2 into a 54. What we want to do is try and break the 54 down so that it has a third root of 2. Okay? So that's where you're going to come in using your perfect squares paper. All right, so we're looking at x cubed right here. Okay, we see that 54 is not on here, but we're going to see how can we break 54 down. And we know that we have to multiply by a 2. So 54 divided by 2 is 30, I don't know what it is. Hold on. Dun, 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 dun. 27. Okay, now our 27 is on our x cubed list. Okay, x cubed, we got 27. So I know the cubed root of 27 is 3. So this part will turn into 3, and these will stay the same. So it looks like this. Now that's ideal, that's what we want, because now our radicals are exactly the same. All we have to do is subtract the coefficients. So we have 3 minus 1. So our final answer is 2 times the third root of 2. Okay, again, we're going to break this down. We know we want part of it to match this. So we're going to take 54 divided by 2 gives me 27. So I'm going to rewrite the third root of 54 as the third root of 27 times the third root of 2 so that these two match. The third root of 27 turns into 3. And now I can subtract. Okay. Now this one, we've got 3 times the fifth root of 2 minus 7 times the fifth root of 5. The radicals are not the same, again. But there's no way we're going to break the 5 down into a 2. And we can't multiply the 2 by anything to make it a 5. So what we're going to do is we're going to change both radicals into the same thing. Kind of like making a common denominator. And we're going to do that by multiplying them by each other. Okay. So I'm going to take this, my third root of 5 square root of 2. Or 3 times the fifth root of 2. And I'm going to multiply it by this fifth root of 5. I'm going to take this and multiply it by this fifth root of 2. Because they have the same index, I can just multiply the numbers underneath. So it becomes 3 times the fifth root of 10 minus 7 times the fifth root of 10. And now you just have to do 3 minus 4, or 3 minus 7 is negative 4 times the fifth root of 10. Okay, so make sure that you go back and look at these while you're doing the problems. Line it up. See if it matches one of these examples. Okay, we're going to do a couple more examples. All right, so we have 5 times the fifth root of 7 minus 7 times the fifth root of 7. We see the minus sign in between there. We also see that the radicals are exactly the same. So all we're going to do is keep that same radical and subtract 5 minus 7. So our final answer is negative 2 times the fifth root of 7. That should be a real easy one. Okay, now our next example, third root of 2 plus 2 times the third root of 128. All right, we see a plus. That means our radicals have to be identical. We have a 2 and we have a 128. Not going to fly. So we need to break this down so that it has a third root of 2 in it. So basically you're going to take 128 divided by 2, gives you 64. Okay, what happened? Haha, okay. So I kept this third root of 2 and the plus 2, and then I broke this down into the third root of 2 that I knew I needed, times my third root of 64. Now this is on my perfect squares paper. Okay, x to the third, I see 64 becomes 4. Okay, so again, I wrote the part in black down again. Kept this third root of 2 because I need that. This became a 4. Now, I have to multiply that 4 and that 2 because this is all one number over here. So it becomes the third root of 2 plus 8 times the third root of 2. And now I just add the coefficients. So I have 9 times the third root of 2. Okay, next problem. I have multiplication instead of addition or subtraction. So this is going back to what you were just doing on the last assignment. Okay, remember you're going to multiply the whole numbers together and you're going to multiply the radicals together. So you're going to end up with 8 times the third root of 432. Now, you could leave it there, but you're not done. It always has to be simplified. It's like a fraction. It's got to be lowest terms. So you're going to go to your x to the third column. Do we see 432? No. So we need to break it down. Can we do 432 divided by 340? No. Divided by 216? No. Divided by 165? No. Or 125, sorry. Divided by 64? I don't know. Let's see what I ended up doing. 27 and 16. Okay, so the 27 was on here. Okay, so I picked that one because it's on my list. This one just comes up because I have to multiply this by this to get this. So remember, the one on the list becomes the whole number. The third root of 27 on the list is 3. So keep my 8. This becomes 3. Keep this. 8 times 3 is 24. That's my final answer. Okay, square root of 20, x to the 6th, y to the 7th. We're practicing again some of these things that were on the last note that kinda did not end up on the last assignment. Okay, so remember the first thing you're going to do is you're going to break it up. The whole number, the x's, and then the y's. Everything's separate. Then we're going to start trying to simplify them. So square root of 20. 20 is not on your square root list, but we can break it down into the square root of 4 and the square root of 5, because remember the square root of 4 is on your x squared list, and the square root of 4 becomes 2. So I've taken the square root of 20 and simplified it to 2 square root of 5. Remember these, what we're going to do is we're going to rewrite them as an exponent, a fractional exponent. So this is going to become x to the 6 over 2. Remember, you want to simplify this. So 6 divided by 2 is 3. We can't do anything else with that. So that's become x to the third. Okay, we're going to do the same thing with y, square root of y to the 7th. That becomes y to the 7 over 2. You're going to do 7 divided by 2, and you're going to get 3.5. So we keep the y to the third, and we take the 1.5 and turn it back into my radical. So now these ones that are in red all go together outside in front, and the ones that are in purple with the radicals all go together under the same radical. So this is your final answer. 2x cubed y cubed times the square root of 5y. Okay, we're going to practice again. The fourth root of x to the 5th over y to the 16th. All right, so the first thing we're going to do is we're going to split them up. Okay, and we can't do anything with the x and the y because they're different, right? So we're going to start by rewriting them. So the fourth root of x to the 5th becomes x to the 5 over 4. Do 5 divided by 4, becomes 1 1/4. Keep the x, and then the 1/4 goes back into a radical. And do the same thing with my 4th root of y to the 16th. It becomes y to the 16 over 4. 16 divided by 4 is 4. Now, the red part, this is what was on top. So this is going to stay on top. This is originally what was on bottom, so that's going to stay on the bottom. So our final answer is x times the 4th root of x all over y to the 4th. Okay, last problem. This one again has multiplication. So that's where you're going to start. They have the same index. So you're just going to multiply everything that's underneath and keep that index. So 16 times 6 is 96. X to the 7th times x. Remember, keep the x, add the exponents. It becomes 8. Y squared times y to the 5th. Keep the y, add the exponents, becomes 7. Now, since we only have one radical, now we're going to break it up like we did the other problem. Okay, 3rd root of 96. We're going to go to our x to the 3rd column. Do we see 96? No, we do not. So we're going to decide how we can divide 96. Can we divide it by 64, by 27, or by 8? And 8 is the biggest one we can do. Okay, remember we like the 3rd root of 8 because it's on that list and it becomes the whole number 2. The radical just stays. 3rd root of x to the 8th gets rewritten as a fractional exponent. And then divide the fractional exponent. So 8 divided by 3 is 2 2/3. Keep the x squared. Take the 2/3, turn it back into a radical. So that became the 3rd root of x squared. Okay, same thing with my y's. Becomes 7 over 3. Divide that. You get 2 1/3. So I have a y squared and a 3rd root of y. So remember, everything outside the radical stays outside the radical. Everything underneath goes back. So I have 2x squared y squared times the 3rd root of 12x squared y. Okay, keep these handy. Remember to get in touch with me if you have questions. Once you've done the assignment and you've turned it in, if you look at the answer key and you want to see a video explanation of that where I walk you through, let me know because I'll make one and post that also. Okay? All right, guys. Good luck. I'll see you later. Bye.